Hello friends, welcome to this chapter. In this chapter, we will learn about CCTV storage and RAID type of storage system. In today's world, all visual and audio data is now in digital format. Each new day, surveillance requires new terabytes of storage space for the thousands of cameras around various cities, major towns, and regional areas, including shopping centers, factories, and prisons, to name a few. The need for data storage grows exponentially with every new megapixel sensor and with every new technology. The surveillance industry is one of the largest consumers of data storage media because of need for constant recording of information from cameras. As these recordings are very crucial and used for investigation purposes, data lost is not affordable. Now most of the CCTV manufacturers are coming up with different ways of storage redundancy. Short-term storage. Short-term storage is the recycling of the available storage space using the first in first out principle, or called FIFO principle. In other words, if recorder have a drive capacity to store only 8 days, then in 8th day recording done at day 1 would have been erased from the hard disk, giving place to record the video footage of day 9. RAID type of storage systems. RAID stands for Redundant Array of Independent Disks. It is a way of storing the same data in different places on multiple hard disks or solid-state drives to protect data in case of a drive failure. These all are managed by a device called RAID controller. RAID controller may be a hardware or software based. Hardware-based RAID has physical hardware or controller which controls and manages the arrays, while software-based RAID uses the resources of the computer hardware systems such as the CPU and memory. There are different levels of RAID, or you can call it as RAID types. There are basically total 5 types of RAID levels. First, RAID 0, RAID 1, RAID 5, RAID 6 and RAID 10. Now let's see each of them and how they works. RAID 0 or stripping method. In RAID 0, data are split up into blocks that gets written across all the drives in the array. As shown here, data block 1 is written across disk 1, while data block 2 is written across disk 2, and in the same way other data blocks are written over 2 disks. RAID 0 is not fault tolerant. It means that if one drive fails, all the data in RAID 0 are lost. It should not be used in mission critical system where data loss is not affordable. Advantage of RAID 0 is that operation speed is faster as there are 2 disk drives for data operation. 1. Or mirroring method. Data are stored twice by writing them to both the data drive or set of drives and a mirror drive or set of drives. If a drive fails, the controller uses either the data drive or the mirror drive for data recovery and continuous operation. You need at least 2 drives for a RAID 1 array. RAID 1 is a very simple technology and offers excellent read speed and write speed that is comparable to that of a single drive. In case a drive fails, data don't have to be rebuilt, they just have to be copied to the replacement drive. The main disadvantage is that the effective storage capacity is only half of the total drive capacity because all data gets written twice. Software RAID 1 solutions do not always allow a hot swap of a failed drive. That means the failed drive can only be replaced after powering down the computer it is attached to. For servers that are used simultaneously by many people, this may not be acceptable. Such systems typically use hardware controllers that do support hot swapping. RAID 5. RAID 5 is the most common secure RAID level. It requires at least 3 drives but can work with up to 16. Data blocks are stripped across the drives, and on one drive a parity checksum of all the block data is written. As shown here, we are using 4 drives: disk 0, disk 1, disk 2 and disk 3. Three of them are used to store data blocks and the fourth one is used to store parity data. Hence, if we are using 4 disks, then only 3 disks can be used to store data. The parity data are not written to a fixed drive. They are spread across all drives as the drawing shows. Using the parity data, the computer can recalculate the data of one of the other data blocks. RAID 5 array can withstand a single drive failure without losing data or access to data. Although RAID 5 can be achieved in a software, a hardware controller is always recommended. In RAID 5, read data transactions are very fast, while write data transactions are somewhat slower. RAID 6. RAID 6 stripping with double parity. It is same like RAID 5 but with a very little difference. RAID 6 is like RAID 5 but the parity data are written to 2 drives. That means it requires at least 4 drives and can withstand 2 drives dying simultaneously. The chances that the 2 drives break down at exactly the same moment are of are of course very small. However, if a drive in RAID 5 systems dies and replaced by a new drive, it takes hours or even more than a day to rebuild the swapped drive. If another drive dies during that same time, you still lose all your data. With RAID 6, the RAID array will even survive that second failure. RAID 10 or combination of RAID 0 and RAID 1. It is possible to combine the advantages of RAID 0 and RAID 1 in one single system, as shown here. Using RAID 0, data blocks are first strapped over each set of drives and the same data blocks are mirrored over each set of drives using RAID 1. If something goes wrong with one of the disks in RAID 10 configuration, the rebuild time is very fast since all that is needed is copying all the data from the surviving mirror to a new drive. This can take as little as 30 minutes for drives of 1 terabytes. Half of the storage capacity goes to mirroring. So compared to larger RAID 5 or RAID 6 array, this is an expensive way to have redundancy. Hope you have liked this chapter. See you in our next lecture.